In previous lecture, I already started propositional equivalence, that is the second topic of mathematical logic. First topic was propositional logic. Here I discussed logical equivalence. Two compound proposition will be equivalent if their truth value is same. That we can check by the truth table. For example, negation P or Q will be equivalent to negation P and negation Q. You can check the truth value. It's 3 false and 1 true. Here also false, 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 true. So we can say these two are equivalent. I also discussed two more examples like P implies Q is logical equivalence to negation P or Q. You can take the truth value, they are same. I also discussed one example from distributive law that P or Q and R is logical equivalence to P or Q and P or R. Check the truth values, they are same. Let's discuss some more logical equivalence. First I will discuss involving negation, conjunction and disjunction. Then next I will discuss using conditional statement, then biconditional statement. So first law is identity law. Like in multiplication, we can say 3 multiplied 1 is 3. Any number multiplied by 1 is same number. 1 is the identity for multiplication. For addition, we can say 0 is the identity for addition. Suppose 15 plus 0, it's same 15. Like here, any propositional variable and true will be same propositional variable. So P and true will be same P. So if P value is true, then true and true it will be true. If P value is false, false and true it will be false. In case of and, true will be true, rest it is false. So any propositional variable and with true will be same propositional variable. That is identity law. Next, for false, P or false. If P is true, true or false, it will be true. If P value is false, false or false, it's false. So you can say true is the identity for and false is the identity for or. Next is dominance law. Suppose we multiplied 15 with 0, it's 0. Any number multiplied by 0 will be 0. So 0 is dominant over multiplication. Now P or true will be true. So any proposition or true will be true and any proposition and false will be false. So true is dominance over or and false is dominance over and. So P or true. When P will be true, true or true, it's true. When P value is false, false or true, it's true. False or false will be false, rest it is true. Suppose any one value is true, it will be true. So false or true, it will be true. Now P and false. When P is true, true and false, it will be false. When P value is false, false and false, it is false. In case of and, true will be true, rest it is false. If one truth value is false, then it will be false. In case of or, if one truth value is true, then it is true. So you can say true is dominance over or and false is dominance over and. Next is idempotent law. P or P is equivalent to P and P is equivalent to P. Let P value can be true or false. Let me take another P, same truth value, true and false. Now P or P. P or P will be true or true, it will be true, false or false, it will be false. Now find P and P. In case of and, true will be true, rest it is false. So true, it will be true, then false and false, it is false. So you can see P or P, it's same as P and P it's same as P. So both are equivalent to P value. So you can say any proposition or with same proposition will be same. Suppose X is given, X or X will be X, then X and X will be same X. So any proposition or and with the same proposition will be same. So it's idempotent law. Next, double negation law. So negation of negation P is equivalent to P. Suppose P value is true, then true negation and negation. Now true negation will be false, then false negation is true. So if P value is true, negation of negation P also true. If P value is false, then negation of negation false. Negation false will be true, then negation of true is false. So when P value is false, negation of negation false is also false. We are doing double negation. In first negation it will be opposite. In second negation again it will be opposite. So we are getting the same truth value. Next is commutative law. P or Q is equivalent to Q or P. P and Q is equivalent to Q and P. So or and both are commutative in nature. Next is associative law. P or Q or R, that is equivalent to P or Q or R. We are just shifting the bracket. Initially bracket was with P or Q. Now bracket is with Q or R. So both are equivalents. Even for and, P and Q and R is equivalent to P and Q and R. You can check this by truth table. Next is distributive law. P or Q and R is equivalent to P or Q and P or R. I already discussed one example of distributive law in previous lecture. There I already created truth table for distributive law. Here we can say or is distributive over and. Here P and Q or R is equivalent to P and Q or P and R. Next is De Morgan law. Negation of P and Q is equivalent to negation P or negation Q. So when we are taking negation inside, this and or symbol is changing. Here it was or, now it will change to and. If it is negation P and Q, then it will be negation P or negation Q. We are adding negation with each proposition, then this and or symbol is changing. And will be or will be and. I already discussed this in previous lecture with a truth table. Next is absorption law. P or P and Q is equivalent to P. Let's check it. For P, true, true, false, false. Then for Q, true, false, two proposition. So there will be 2 part to 4 rows. Now P and Q, in case of and, true will be true, rest it is false. Next P or P and Q. Here P value as true or anything, it's true, so we'll write true. Then false or false, it will be false. Then false or false, it's false. Here true, false, false. Here also true, false, false. So I can say P or P and Q is equivalent to P. You can check the second absorption law, that P and P or Q is equivalent to P. So P or Q will be true, false, and P value is true, false, false. Now both and will be true and true, it will be true and true, it will be true. Then false and true, it will be false and false, it will be false. So it's same as P, true, false, false. Next is negation law. P or negation P is true and P and negation P is false. In case of and, true will be true, rest it is false. So here true and false will be false. It's P and negation P is equivalent to false. Then P or negation P is equivalent to true. Suppose P value is true or negation P will be false. True or false, it's true. If P value is false, then false or true. Negation P will be true, false or true, it will be true. Anyway, in case of or, if one value is true, it will be true. And in case of and, if P is true, then its negation will be false. So true and false, it's false. If P is false, then its negation will be true. So in case of and, in any way. If P is true, then its negation is false. If P is false, its negation is true. We are getting one false. When false and something, it will be false. That's why P and negation P is always false, and P or negation P is always true. It's our negation law. So any proposition or with its negation will be always true, and with its negation will be always false. Just remember this logical equivalence with its name. Today I discussed logical equivalence involving and, or, and negation. In next lecture I will discuss including conditional statement and biconditional statement. If today lecture is helpful for you, please like, share and subscribe. Thank you.